Good afternoon, guys. Good afternoon. Today we are in the lecture 16 of Unit 2. So we have completed the Unit 1 successfully. Now we have entered into the Unit 2. Unit 2 of fluid mechanics. Right? So in the last class we have discussed all the basics of the properties of fluids. The gauges, the pressure gauges, the vacuum gauges, atmospheric gauges, and we have discussed various types of manometers, discussed various types of mechanical pressure gauges, and we have completed problems also. Today in this class, we will start a new topic, that is fluid. So in the initial classes, already we have in the initial classes, we have discussed about the basic definitions, what is fluid mechanics, what is fluid dynamics, what is fluid statics, what is fluid dynamics, like this. Now we will go in deeper about the fundamentals of fluid kinematics in this class. If you see the concepts in Unit 2, is the first one is a fluid kinematics, description of fluid flow. So already said in the last class, so we are dealing with the flow of fluids. We are dealing with the fluids which are in motion, which are in static. So rest lo unna fluids tho manamu problems chestunam, motions tho unna fluids tho manamu problem chestunam. Whenever a body is submerged horizontally, vertically, inclinedly, so how the reaction takes place, what are the center of pressure anedi manamu discuss chesam. So in this session we will discuss about the description of a fluid flow, how the fluid flow acts based upon the two categories. Next one, what are the different definitions of streamline, path line, streak line, and stream tube. So we will discuss the definitions of what is a path line, what is a streak line, what is a streamline, stream tube, with examples in this unit. Next concept is classification of flows. So in the universe, generally, how many types of fluid flows are there? So we are having basically 6 types of fluid flows. Those are steady and unsteady flow, uniform or non-uniform flow, laminar, turbulent flow, rotational, irrotational flow, like that. So we will discuss each and every study of flow in detail with the problems also. Next thing, continuity equation. So we are having a derivation on the fluid flow, that is continuity equation. In this continuity equation, we will see the various flow rates of the fluid for one-dimensional flow, two-dimensional flow, three-dimensional flows. So like this, we are having some of the topics in the fluid kinematics. Next, stream and velocity potentials flow network analysis. Here we are having a derivation. Based on the derivation, you are having the problems on flow net analysis of the fluid. Next one is fluid dynamics. So in this fluid dynamics, so the study of objects, the study of fluid in motion, right? Here the surface and body forces, how they are reacting, right? So we have the two scientists, namely Euler and Bernoulli. So we are having two scientists about who said about the motions of the fluid, Euler's equation and Bernoulli's equation. So we will discuss their derivations and also their problems. Next topic is momentum equation and its application. So how the momentum equation takes place and what are the problems associated with the momentum equation. Next, forces on pipe bend. So whenever the fluid is flowing in a different pipe channels, whenever the fluid is flowing in a different bend pipes, how the forces are acting on it, what are the pressure, what are the end results on this bends. So like this, we'll see all these types of fluid flow problems in this fluid kinematics, right? Yes. So we'll start the thing. So As already discussed, what is a fluid mechanics? Fluid mechanics means the science that deals with the behavior of the fluid at motion. It is a science that deals with the behavior of the fluids in the motion. That is a fluid mechanics. Rest. So we will say other definition as a rest. Rest and a static position lo unnana ardham. That is statics here. Rest or it is in halt. Rest, halt or statics. The science that deals with the behavior of fluids at rest or in motion. Motion lo unnappudu emantam, we are calling them as a fluid dynamics. When they are in rest, we are calling them as fluid statics. And the interaction of fluids with the solids. And the interaction of fluids with the solids or other fluids at the boundaries. So the study of science that deals with the fluid at rest or in motion and the interaction of fluids with the solids or other fluids at the boundaries. So boundary, for example, so you are having this is a boundary in a fluid. So here it is a liquid, here it is a other liquid, or here it is a other solid. So whenever they are touching in a boundaries, so how the reaction takes place, right? That is nothing but fluid mechanics. Here the kinematics means the study of fluids in motion, where pressure forces are not considered. So the fluid kinematics deals now here, whatever the second unit 2 we are discussing, here is fluid kinematics and fluid dynamics. So here what is we are saying, the study of fluids in motion where the pressure forces are not considered, then it is nothing but fluid kinematics. Here, next, the study of fluids in motion where the pressure forces are also considered are nothing but fluid dynamics, right? Now, if you see the nature of the fluids are subjected to shear. దీనికి ఫస్ట్ క్లాస్ లో మనం చెప్పుకున్నాం how the book example, taking a book, opening the book, and if you are pressing a hand on the papers will automatically move towards your fingers, how they are moving forward. That's nothing but a shear. So fluids subject to the shear. Fluids subject to pressure imbalance flow. So whenever you are taking a fluid in any cover, in any plastic cover, and you are tightening it, so whenever you are making your hand moving in different ways, the pressure of water also moving according to the hand movements, balancedly or imbalancedly. So pressure is subjected to, fluids are subjected to pressure imbalance also. Next, in kinematics, we are not concerned with the force. So manamu generally we concern only in the motion. So force we are not considering. Thus we are interested in visualization. So whatever the fluid kinematics problem we are having, everything we have to go in a visualization. Just we have to visualize according to the problem given and we have to get the solution, right? Next, classification of flow pattern. So how the fluid flow pattern we will see now. There are different pattern flows usually characterized by time versus distance. So a classification of patterns అనేది దేని మీద ఆధారపడి ఉంటుంది? Depends on the time and the distance. The pattern flows are usually characterized by the time and the distance. First one, if we take the time, a flow is steady if the parameters describing it, example, the flow rate, the velocity, the pressure, etc., do not change with time. So time to change kaani flow rate, velocity of a fluid, pressure of a fluid, this will discuss with the time. Otherwise the flow is unsteady. So first one is the time. A flow is steady if the parameters do not change in time. So time to change kaanatuvanti parameters ni we are calling them as a flow steady. Next, distance. In the distance here, a flow is uniform if the parameters describing the flow do not change with the distance. So distance to change we are calling them as a uniform flow. In non-uniform flow, the parameters change from point to point along the flow. ఇది మనకి ఎప్పుడు ఫ్లూయిడ్ డైనమిక్స్ లో జరుగుతుంది. సో యాజ్ ఆఫ్ ఫ్లూయిడ్ కైనమాటిక్స్, ఫ్లూయిడ్ ఫ్లో స్టడీ అని ఎప్పుడు చెప్తాము? whenever the parameters like flow rate, velocity, pressure does not change with the time, we are calling them as a steady flow. Next, distance. Whenever the fluid is uniform, a fluid flow is uniform ఎప్పుడు చెప్తాం? whenever it does not change with the distance, we are calling them as a uniform fluid flow. Next, existence of flow. Next topic is the existence of flow. So how the flow is existed? How we can say the flow is existing? Existing and then the living. Now the fluid must obey the law of conservation of mass in course of its flow, as it is a material body. Ante kada, a flow means it is a material body. Some material, some medium, some quantity is passing from higher end to lower end. Right? The fluid must obey the law of conservation of mass. So it should obey the law of conservation of mass. Next, second one. For a velocity field to exist in a fluid continuum, the velocity components must obey the mass conservation principle. So whenever the flow, automatically we are using the parameters, that is the flow rate, that is the velocity, and that is the direction or distance. We must obey the mass conservation principle. We must obey the mass conservation principle. Next, third one. The velocity components which follow the mass conservation principle are said to constitute a possible fluid flow. So the components of velocity, the component parameters of velocity must follow the mass conservation principle that constitute a possible fluid flow. Next, velocity components violating this principle are said to describe an impossible flow. So whenever these components are obeying the law of conservation of mass, then we can say these are possible fluid flows. So whenever the velocity components are violating and not agreeing the principles, then we are saying them as an impossible flow. For example, take any petrol, so it is flowing. Take any lubricant, so viscous nature ఎక్కువ ఉంటుంది కాబట్టి fluid flow అనేది జరుగుతుంది, but very slow. It is obeying the fluid flow principle. But if you take any solid material, ask it to flow, obviously it does not flow. Why? Because it is not obeying the velocity components. In a simple example. Next, the existence of physically possible flow field is verified from the principle of conservation of mass. So what the next point is saying? The existence of physically possible flow field, so that is a velocity field, is verified from the principle of conservation of mass. It is saying that the velocity field is verified from the principle of mass. Now we'll see the velocity flow, the continuum hypothesis. Now if you see the velocity flow, now take an object, see this object, we are having x-axis, y-axis and z-axis. So here in the space or in the liquid, the fluid is allowed to move from one place to other place. Now in this hypothesis, the fluid is made to tighten the fluid particles that interact. So the fluid is made of tightly packed fluid particles that interact with each other. So take a glass of water. In that glass of water, the molecules, the fluid particles are tightly packed with each other. Each particle consists of numerous molecules, right? Each particle in the fluid consists of a numerous number of molecules, and we can describe the velocity, acceleration, pressure, density of these particles at the given time. We are having enormous number of fluid particles with the molecules, so we are considering the velocity, the acceleration, the pressure, the density of all these particles with respect to the time. Now if you take in a 3D space or in a fluid, taking the x-axis, y-axis and z-axis, starting from a 0, here the particle A is moving at a time t. So ఇలాంటి ఆబ్జెక్ట్ ఈ స్పేస్ లో కొన్ని hundreds, thousands, lakhs ఉంటాయి అన్నమాట. So we are considering a one particle. Just to take this, see this blue line is passing generally in a fluid like this. The particle A at the time t it is taking, it is moving in a particle path, a certain path, and it is taking particle A at a time t plus delta t, change in the time, t plus 2 minutes. అంటే ఇక్కడ 1 minute అనుకుంటే ఇక్కడ 1 plus 1 2 minutes లాగా, t plus delta t. Now if you see the time with respect to the distance RA of t plus delta t, right? So from here it is calculated with this one, from here it is calculated to that corner. Now with these things, now see the velocity v is equals to u v w. V is equals to 3 axis u v w. So we are taking u of xyz I cap, v of xyz t j cap, w of xyz to the time t k cap. Now what is the v here? V of x, y, z, t things. Now the v is equals to mod of v, that is equals to u square plus v square plus w square to the power of 1 by 2. Now when derivating, dRA by dt is equals to VA, dRA by this one, dRA by dt is equals to VA. Next, you see the velocity field streamlines. It's like this, the particles, whatever we have discussed in this previous class, in the previous slide, this one, this velocity of existence we can show with this figures. Now see the various definitions of the velocity field. The first one is a streamline. So what is the meaning of streamline here? The streamline, the line that is everywhere tangent to the velocity field. The line that is everywhere tangent. So for example, this for a streamline, so everywhere it is tangent. Wherever you are taking a curve, every point it is making a tangent. The line that is everywhere tangent to the velocity field. If the flow is steady, nothing at the fixed point changes in time. But in an unsteady flow, the streamlines give change in the time. So steady flow lo unnappudu nothing happens when there is a change difference. Okay. But in unsteady flow, the streamlines change in time. In unsteady flow, the streamlines change according to the time. Analytically, for 2D flow, integrate the equations defining the lines tangent to the velocity field. So the velocity are moving in a certain direction, so constantly, uniformly. The tangents, whatever you are making on it, you are getting the streamlines due to the change in the time. Next, thereby what is written? Dy by dx is equals to v by u. So dy by dx is equals to v by u. Now, so generally, in order to study the fluid flows, we are having two types of theories. One is Eulerian theory, other one is a Lagrangian theory. So Eulerian is a scientist given some derivations, some contribution to the fluid flows, and also Lagrangian also is given some of the concepts related to the velocity fluid flows. So here in the Eulerian method, the velocity factor is defined as the function of time and space coordinates. So in the one of these space coordinates, everything is imaginary. That is v of u plus v plus w, u v w to the x, u v w t x, u v w t y z. Like this, these are all imaginary things. which we took from the space coordinates along with the function of the time t. Next, what is the streamline definition? It is saying a streamline at any instant can be defined as an imaginary curve or line in the flow field. అంటే ఒక వాటర్ ఫ్లో అవుతున్నప్పుడు సో ఆ వాటర్ మీద మనం ఫిజికల్గా లైన్ చూపించలేం కాబట్టి we are making some imaginary lines according to the water flow. It may be straight water flow, it may be curved water flow, or maybe some other pressurized water flow. What it is there, so showing the imaginary line showing field so that the tangent to the curve at any point represents the direction of the instantaneous velocity at the point. So whatever the line drawn tangent to the curve will shows the instantaneous velocity and a very high amount of velocity at that point. That is the definition of Eulerian method. In unsteady flow, so when the water is unsteady flow, where the velocity vector changes with time, where the velocity vector changes with the time, the pattern of streamlines also changes from the instant to instant. Next, in a steady flow, the orientation of the pattern of the streamlines are fixed. Steady flow lo em jarugutundi, the orientation of the pattern streamlines are fixed. Next one, stream tube. Next definition is the stream tube. So whenever the water is going through the pipe or a tube, what happens? Now see, a bundle of neighboring streamlines may be imagined to form a passage through which the fluid flows. This passage is known as stream tube. What is the stream tube definition here? A bundle of neighboring streamlines. So these streamlines, whatever in the streamline definition, here a group of streamlines are passing parallel, imagined to form a passage through the pipe. This passage is nothing but a stream tube. Then what are the properties it should have? The steam tube is bounded on all sides by streamlines. Ante kada? So మీరు water pipe loంచి water వస్తుంది with high pressure అంటే what is the meaning? In the pipe we don't have any gap. So water is completely filled the circumference, inner circumference of the pipe, and thereby the water is going outside. So here there is no meaning of the boundaries are empty, right? Here the stream tube is bounded by on all sides of the streamline. See the figure. So the circumference, inner circumference of the tube lo, the lines are completely bounded. Next, fluid velocity does not exist across the streamline. The fluid velocity em jarugutundi, it does not exist across the streamline. No fluid may enter or leave the stream tube except through its ends. Sometimes once it is passing at one cross section of the pipe, it has to leave to the other end only. That is the principle. It does not exist the streamline fluid velocity. No fluid matter cannot run outside the pipe. Next, what is the third point? The entire flow in a fluid, admitting very late. The entire flow in a fluid field may be imagined to composed of flows through the stream tubes arranged in the arbitrary position. So these are some of the main properties of steam tube. Next definition is streak lines. Next definition is a streak line. So what are the streak lines? A streak line is a laboratory tool used to obtain instantaneous photographs of marked particles that are passed through a given flow field at some earlier time. Literally, buoyant smoke or dye is continuously injected into the flow at the given location to create the picture. So what are the streak lines here? The streak lines are the tool used to get instantaneous photographs of marked particles. So just like your negative, just like your photo negatives, photo marks. So the particles are passed through the given flow field at some given earlier time. Next, path lines. The path line is traced. It is a line traced by a given particle as it flows from one point to another. For example, if you take a ant, an ant. So ant water lo dip chesi bite వదిలేస్తే whenever the ant is moving from one place to other place in a point path line, so water marking anta line anta padutundi, depends upon the how much length it is going. Then we can say that it is a path line. అర్థమైందని చెప్పిన ఎగ్జాంపుల్. సో whenever you take an ant and dip in a water and leave it, అప్పుడు నేల మీద పాకుతూ వెళ్తుంది. సో ఆ నేల మీద వెళ్ళినంత వరకు it is making a path, just like a path. Just an example how I can imagine చేసి చెప్తున్నాను. Just you also think in that manner. Next, at line path, this method is Lagrangian technique in which the fluid particle is marked and then the flow field is produced by taking the time exposure photograph of its movement. See here, if you take the P1, it is the path is moving like this, it is moving like this, making a turn, and it is flowing like this. If you take a P2, P2 is making in this direction. P3 is making down direction. P4 is making in this direction. So like this, you are having the exposure photograph of this movement. And what is the definition? You can say simply a path line is a trajectory of a fluid particle of a fixed identity. The path line means the path line is a trajectory of a fluid particle of the fixed identity. So trajectory means the path, how you are describing from initial position to the exit position. Trajectory. Next, a family of path lines represents the trajectories of different particles, say P1, P2, P3. So this is example how they are showing how the paths are moving. So we can show in a different ways how it is moving, right? Next, what is the difference between path line and a streamline? The path line refers to the path followed by a fluid particle over a period of time. So at a given time, how the flow of fluid particle is taking place, that is a path line. Streamline and enti, the streamline says here, the streamline is imaginary curve in a flow field for a fixed time, tangent to which gives the instantaneous velocity at a point. So the streamline is saying this imaginary curve made where the tangent to which gives the instantaneous velocity at that point, that is a streamline. Path line. Two path lines can intersect each other. So indak manam ikkada two path lines are intersecting each other, right? So see here, the two path lines are intersecting at this point. So two path lines can intersect each other as or in a single path line can form a loop as different particles or even same particle can arrive at the same point of different instant time. Here, two streamlines can never intersect each other as the instantaneous velocity vector at the given point is unique. So whatever the velocity is coming from this imaginary streamline, it is unique. That's why they will not get intersected at any point. It depends upon their capacities. That is nothing but streamline. Next, methods of describing the fluid flow. So how do we describe the fluid flow? So based upon the general definitions and the concepts, when a fluid flow is in motion, individual particles in the fluid move at different velocities. Ante kada, when the water is flowing from upper end to lower end, ante oka కాలువలో వాటర్ పోతుంది, లేదంటే ఒక కొండ మీద నుంచి వాటర్ వస్తుంది కిందకి, then the water is flowing at certain velocity and also the particles moving in the water also moving with some velocity irrespective of the size and shape. Then at a different instance the fluid particles change their positions. Ante kada, whenever it is hitting at any rocks inside the layer of the water, or whenever it is taking changes internally during the movement, automatically they change their position. Next one is, where is the cursor? Yeah. This one is completed. In order to analyze the flow behavior, a function of space and time, in order to analyze the flow behavior, a function of space and time, we follow one of the approaches. What are the approaches? Lagrangian approach. Second one is Eulerian approach. First one is Lagrangian approach, is a scientist name. Second one is a Eulerian approach. So generally we use Eulerian approach for the fluid mechanics concept. We'll see this one, basic definitions. So what is this Lagrangian? Lagrangian approach is saying, in the Lagrangian approach, a fluid particle of a fixed mass is selected. A fluid particle of, these are all imaginary. ఏది మనకి fluid particle నుంచి ఒక liquid medium నుంచి ఒక particle మనం తీయలేం physical గా, right? In a Lagrangian method, what it is saying, a fluid particle is derived from a fluid particle is taken from the mass is selected. We follow the fluid particles during the course of motion with the time. Now if you see this is a chamber. Inside this pipe the water is flowing. Now take this is a one fluid particle, which is in a three-dimensional space, right? It is flowing uniformly. These directions are giving uniform movement. What is saying? The fluid particle of a fixed mass is selected. We follow the fluid particle during the course of motion with time. The fluid particles may change their shape, size and state as they move. Together, this particle ఇక్కడ ఉన్నప్పుడు ఇలా ఉంది, ఇక్కడ ఉన్నప్పుడు పొజిషన్ చేంజ్ అవుతుంది, ఇక్కడ ఉన్నప్పుడు మళ్ళీ పొజిషన్ చేంజ్ అవుతుంది. Their size may change according to their move. As a mass of fluid particles remains constant throughout the motion, the basic laws of mechanics can be applied to them at all the times. So mass change avukunda, whenever the other things, shape, size, state of matter changes, doesn't happen, and this will be used for the basic laws of mechanics. The task of following the large number of fluid particles is quite difficult. Therefore, this approach is limited to some special applications. For example, re-entry of the spaceship into the Earth atmosphere. So what is it saying? Re-entry of the spaceship into the Earth atmosphere. Earth's atmosphere, and follow measurement system based upon the particle imaginary. So that is an example of this particle flow. So next you are having Eulerian approach. I think the time is out. We'll discuss these things tomorrow. Okay. So with this we'll stop here. So today your attendance is only 1, 2, 3, 4. Regular ga vastunna valle vastunnaru. Your class is I think 25. Only regular students are coming. Ask your friends to join the class. Screenshot is taken, attendance is taken. So once the video is completed, once the class is completed, the link is uploaded in the YouTube and it is forwarded to your group. Just open it